the only force acting on the ball is only gravitational force, which means we can apply the law of mechanical energy conservation. So let us equate the energy of A with energy of C. Now at the point A, the object was released from rest, so we can write kinetic energy at A will be 0 plus potential energy of the ball at A is mgh. So let's write that down. Now at C, C is the point just close to the ground, so we will consider the potential energy of the point C to be approximately 0 plus kinetic energy at the point C will be half mv square, where v is the speed of the object just before hitting the ground. And let's simplify this. We will get mgh comes out as half mv square. So basically this half mv square is the kinetic energy of the object just before hitting the ground. Now, in the question, it is mentioned after each bounce, 75% of the kinetic energy is lost to the surroundings. Let us label one more point in this diagram. So, we have considered point C, which is the position just before hitting the ground. Now, let us consider a point D, which is just after hitting the ground. So, at point D, the ball is moving upwards with, let's say, a speed of V dash. So let me repeat, V dash is the velocity of the ball just after hitting the ground. Now we are going to consider this point D until it reaches the maximum height. So let's say point E is the position of the ball when the ball reaches the maximum height after the second bounce. So from D to E, we can apply the energy conservation. So let us repeat the same principle. Earlier we applied the energy conservation from A to C. Now we will apply the same steps for D to E, where D is the point just after hitting the ground. So at the point D, we are going to consider potential energy to be approximately 0 because point D is close to the ground. And let's say kinetic energy of the ball at the point D will be, let's call this as KD. Now at the point E, which is the highest point, kinetic energy will be 0 and potential energy will be mgh dash. Now, in the question, it was mentioned that after each bounce, 75% of its kinetic energy is lost to the surroundings. And earlier, we had figured out this is the kinetic energy of the object just before hitting the ground. So, let me write kinetic energy before hitting the ground is equal to half mv square, which is also equal to mgh from the law of conservation of mechanical energy. Now, kinetic energy after the bounce, what will that be? In the question, it is mentioned 75% of the energy is lost, which means 25% energy is still left. So kinetic energy afterwards will be 25% of the before kinetic energy. 25% will be written as 1 by 4, and before kinetic energy is half mv square, which is equal to mgh. So we'll write mgh here, which means the kinetic energy after hitting the ground is equal to mgh divided by 4. Now, if we go back up at the point D, which is the point just above the ground, kinetic energy at the point D will be equal to this mgh divided by 4. So let's write, instead of kd, we will write mgh divided by 4. That will be equal to mgh dash. And now let's simplify this. Mg will get cancelled out, and then we will get the expression for h dash as h divided by 4. And what was h dash? H dash was the height of the ball after the first bounce. So let us repeat the entire motion of the object. So the ball started from a height h, it hit the ground, it bounced up until it reaches the point E, and the height of the point E was h dash, which we have figured out was h by 4. So initially the height was h, but after the bounce, after the first bounce, the maximum height is h by 4. Now the question was to find the height after the second bounce. So let us now summarize. Initially the height was h, after the first bounce it went to h by 4. Now we can just generalize from h by 4 after the second bounce what is going to happen. So if you analyze this, after the first bounce, 1/4 of height was left. Similarly here, after the second bounce, we will say 1/4 of h by 4 will take place, which means h upon 16. So just to elaborate, let me draw a diagram. If the squash ball is dropped from a height of h, it is going to bounce up with, let's say, a distance of h by 4, and then it goes back down. After the second bounce, it goes back up by a distance of h by 16. Now the question was, what is the height reached by the ball after its second bounce? It is h by 16, which is option A. And now let us summarize what we have learned so far. Apply work energy principle when resistive forces like friction, air resistance are present, and this is the principle. The total work done by all the forces acting on the object should be equal to change in the kinetic energy. On the other hand, when resistive forces are absent, so non-conservative forces are absent, in that case, we will apply the mechanical energy conservation, which is simple. Initial energy needs to be equal to the final energy. And then we discussed how to figure out the work done by the conservative forces. So this is the formula for work done by the gravitational force and work done by the spring force. And let me write down the basic formula. Work done by any conservative force will be equal to negative of change in potential energy. So in case of gravitational force, the U will be GPE. For springs, the U is EPE. So here we have a stationary mass of 1 kilogram. It is pulled along a frictionless 3-meter inclined plane by a constant force of 6 newtons. At the top of the plane, the mass has been displaced by a height of 1 meters. We have to figure out the speed of the mass at the top of the incline. Now, step number 1 is to identify the different types of forces acting on the object, because basis that we will choose either to use the mechanical energy conservation or the work energy principle. So on the object, the first force acting is already shown, which is the applied force 6 Newton. Then we have the gravitational force, which is the weight of the object. So that will be 1g. And then we'll have the normal reaction. And that's it. There is no friction acting on the object since the surface, the inclined plane surface, is frictionless as it is mentioned in the question. Now remember the rule: if conservative forces are present, if only conservative forces are present, then only we apply the mechanical energy conservation. So in this case, if you check the 6 Newton force which is being applied on the object, that is a non-conservative force. So we cannot apply the mechanical energy conservation. Now the only thing left is, of course, the work energy principle. So let us write down the approach. So work done, total work done by all the forces acting on the object should be equal to the change in kinetic energy. Change in kinetic will be final kinetic energy minus initial kinetic energy. Initial kinetic energy is zero. As they have mentioned, the object was stationary at the starting point, and final kinetic energy, let's say, is half into m into v square, and it is the v, which is the speed at the top, which we have to figure out. So now let us try to figure out the total work done. There are three forces acting on the object. We have the normal reaction, we have the applied force, and 1g. So let's write down the total work done will be equal to work done by the normal reaction plus work done by the gravitational force. Let's write mg plus work done by the applied force of 6 newtons. This is the total work done. So let us find individual work done. In case of the normal reaction, work done, let me write down the basic formula for work, which is force into displacement into cos theta. Now, in case of normal reaction, you can see normal reaction is always perpendicular to the contact surface. So the object is moving along the incline upwards. Hence, we can say that the angle between the normal reaction and the displacement, this angle is 90 degrees. So in case of normal reaction, the work done will be n multiplied by displacement, which is 3, multiplied by cos 90. Cos 90 is 0, which means work done by the normal reaction is equal to 0. Now remember this as a rule: work done by normal reaction is always 0, since normal reaction is always perpendicular to the contact surface. Now let us try to figure out the work done by the applied force, which is 6 Newton. So work done by the 6 Newton force will be 6 multiplied by 3, which is the displacement, multiplied by cos of 0. Why the angle is 0? Because the 6 Newton is being applied up the incline. Even the displacement, even the object is moving in the same direction. So that is why theta will be 0. And this we can write as 18 Newton. So this is the work done by the applied force. Now, to find the work done by the gravitational force, there are two approaches. Method number 1. Let us use the formula for work done by conservative force is equal to negative of change in the potential energy. In this case, it is the gravitational force which we are dealing with. So this should be equal to negative of the change in GPE. So let me write, this will be equal to GPE initial gravitational potential energy minus the final gravitational potential energy. So initially the object was over here on the ground. So the initial gravitational potential energy we can write as 0 minus the finally the object is over here. So the GPE will be mgh, where the height is 1 meter. So we will write negative of m into g into 1. Hence, now we can say that the work done by the gravitational force is nothing but negative of mg, which will be equal to mass is 1, and let us take g as 10. So the work done will be negative 10 newtons. Now let us put the values of all these expressions. Work done by normal reaction was 0, plus work done by the gravitational force was negative 10, plus the work done by the 6 Newton force was 18. This was equal to the change in the kinetic energy, which we had figured out was half mv square. So let's write down half. Mass is 1 multiplied by v square. So on the left hand side, we have a 18 minus 10, which we will get as 8. This can be written as v square by 2. So from this, we can write v square is equal to 16, and then if we take square root on both sides, the value of speed will come out as 4. And if we look at the options, it is option B, which is 4 meters.